Good day and welcome to our online class for General Physics 1. In this video, we will be talking about vectors. There are two classifications of physical quantities that exist. First, we have the scalar quantities and also we have the vector quantities. Scalar quantities are quantities that can be described by their magnitude and of course, their appropriate units. Examples of scalar quantities are mass, temperature, time, and many more. On the other hand, vector quantities are quantities that can be described by their magnitude together with their appropriate units and also their direction. Examples of vector quantities are force, displacement, velocity, acceleration, etc. Graphically, a vector quantity can be represented by an arrow. The length of the arrow represents the vector's magnitude, while to where the arrow is pointing represents the vector's direction. To denote a vector, we use uppercase letter in boldface or with an arrow on top. The magnitude of the vector is denoted by an uppercase letter in italics or with two vertical bars enclosing the letter. One easy way to specify the direction of a vector is by the angle the vector makes with a fixed reference line, which is usually a horizontal line. For example, we have here a vector f with a magnitude of 10 newtons at an angle of 30 degrees above the horizontal. 30 degrees above the horizontal is the direction of the vector, and 10 newtons is the magnitude of the vector f. Vectors have properties, and here are some of those properties. Number 1, vector equality. Two vectors are equal if their magnitude and direction are the same. Number 2, vectors can be multiplied by a scalar quantity. If vector A, for example, is multiplied by a scalar m, there are three possible outcomes. Letter A, if m is positive, then m times vector A is a vector with magnitude m times the magnitude of A and has the same direction as A. B, if m is negative, m times vector A is a vector with magnitude the absolute value of m times the magnitude of A that is oppositely directed to angle A or to vector A. And lastly, if m equals 0, m times vector A is a vector of 0 magnitude and arbitrary direction. Third property, vectors can also be added. If we let C be the sum of two vectors, A and B, that is, vector C equals vector A plus vector B, then vector C is called the resultant vector of vectors A and B, and vectors A and B are called the components of vector C. The process of replacing a resultant with its component is called resolution. That is, angle C is resolved into its component vectors, vector A and vector B. To determine vector C, we may use parallelogram law or its equivalent, the triangle law of addition. In parallelogram law, the resultant vector C is a diagonal of the parallelogram formed by the component vectors A and vectors B as shown. In triangle law, the tail of vector B is placed at the tip of vector A and vector C is the vector that completes the triangle, drawn from the tail of vector A to the tip of vector B. We get the same result if the tail of vector A is placed at the tip of vector B and angle C is drawn from the tail of vector B to the tip of vector A. Vector addition has some properties also. Vector addition is commutative. That is, if vector A plus vector B equals vector B plus vector A. Vector addition is also associative. That is, if we add the sum of vector B and vector C to vector A, we get the same result if we add the sum of vector A and B to vector C. For getting the resultants of three or more vectors, we can use the Polygon rule, which is an extension of the triangle law and a consequence of the associative property of addition. The resultant of three or more vectors, if configured in a tip-to-tail manner, is the vector that completes the polygon drawn from the tail of the first vector to the tip of the last vector. Vectors can also be subtracted. However, vector A minus vector B is equal to the vector A plus the negative of vector B. That is, vector subtraction is the same as vector addition, except that the negative of vector B is in the opposite direction of vector B. So that is all for vectors. Thank you for listening, and please watch the second video where we try to solve examples including vectors or evaluating the resultant of vectors using the triangle law. For questions, you may contact me or DM me in my messenger in our group chat, or you can comment on the post in our Google Classroom. Thank you and happy learning!